We are going to get started with chapter 12 today, which in the first section we're going to go over distance and midpoint formulas. This is something that you also probably talked about in geometry because you were dealing a lot with like shapes on the coordinate plane, and you probably had to look at like the length of sides and see like if they were similar, congruent, those kind of things, so you could show that it was like a rectangle or a square. So some of these formulas might look familiar because you may have seen them in the past. If not though, when you're using the distance formula, you're talking about points on the coordinate plane, and it could be any 2 points. So they use x1, y1, x2, y2 to kind of differentiate the 2 points. And it doesn't matter, like when you're looking at a problem, which one you make x1, y1, and which one you make x2, y2. Usually what I do is the first point they give me, I call x1, y1, and then the second point is x2, y2. Now I use this formula to plug it in, and then this will tell me how far apart those points are from each other. So we're doing our x's, we're subtracting those, and then we're squaring the quantity, and then we subtract the y's the same way we did with the x's and square that. We add them together, and then it's all underneath a big square root sign here. Okay, so let me show you an example. I have the points 1, 5, and 4, 1, and I want to figure out how far apart they are. So if I thought about this for a second, if I graphed these, I could look on the coordinate plane and like see how far apart they are. The problem though is I can't like count perfectly diagonally through 2 points on the coordinate plane. So this is why we have that distance formula to help us get the exact measurement. So underneath the square root sign, well, first I'm going to label this first point x1, y1, x2, y2. If you just want to grab one of those over there from the blue. All right, so underneath the square root sign, I'm going to do my x2 minus my x1. So x2 is 4, and x1 is 1. So I'm going to do 4 minus 1, and then that's squared. And then for my y's, I'm going to do 1 minus 5, and then that's also squared. So I'm going to do my subtraction here first. I'm going to just kind of simplify this. So 4 minus 1 would be 3, so I have 3 squared. And then 1 minus 5 would be negative 4. So when I do this, because I'm squaring those quantities, you should always get a positive number underneath the square root sign here. You should never get a negative answer because you're squaring the number, so that's going to always make it be positive. And then we're adding them together. So 3 squared is going to be 9. And negative 4 squared is going to be 16. So I have 9 plus 16 here. So 9 plus 16 is 25, and the square root of 25 is 5. Now, if my square root does not come out to be a perfect square, like this one was, because this one was 25, we would want to break down the square root by simplifying it. So we're not necessarily looking for like a decimal answer. They just want you to leave it in square root form. So that's when you guys would look, through like your perfect square list and see if there's any that go into it, and then try to break that down if you can. Why don't you guys take a second and try number 2? Okay, so I'm just kind of putting mine in up here right now. So I ended up underneath the square root with 25 plus 4, which is 29. So then 29, if I go through like my list of perfect squares, so 4, 9, 16, 25, 36, 36 gets too big for 29. So I don't think any out of that list above, like before that, so 4, 9, 16, 25, none of those are going to go into 29. So I'm just going to leave that one underneath the square root. I can't really break that one down like I could with the 25. Now, if you guys take a look at number 3 here, we're still using that same formula. They've just thrown in different types of numbers. I mean, we still have numbers here, but we also have these square roots attached. So I want to go through this one with you guys so you can see what's going to happen with those terms that have the square roots of 3. So I'm still going to label this first coordinate x1, y1, and the second one x2, y2. Okay, and then underneath the square root sign here, I'm going to do my 6 minus negative 2 squared. So that's normal. That looks like what we were doing. Now for the y terms, they have those radicals attached to them. So I'm going to do negative 5 square root of 3 minus 2 square root of 3. And then that's all squared. So for the first term there, 6 minus a negative 2, that's going to end up turning to 6 plus 2. So that becomes an 8. So that's 8 squared. Now for the second term here, because the radicals are the same, like I have square root of 3, square root of 3, I can combine the first numbers, like the whole number sitting out front. So I can take negative 5 minus 2, which would be negative 7, and then square root of 3, and that's squared. So 8 squared is going to end up being 64. And with the negative 7 square root of 3, because it's squared, the negative 7 gets squared, and the square root of 3 gets squared. So negative 7 squared is going to be 49. And anytime that I square something that's underneath a square root sign, they basically cancel each other off. Okay, so the 3 that's underneath the square root sign, that's going to come out. And since that 7 or that negative 7 squared is in the front, I'm going to have to multiply that 49 times 3. So then now it says underneath that square root sign 64 plus 147. And that's going to be 211. Okay, and 211, I can't break that one down at all. Like there's no perfect squares that go into 211. Even if I go through my list and I start at 4 and I go all the way up to 200, I'm not going to find anything that works perfectly. So I'm going to just leave it right there. All right, so that's the distance formula. That tells you how far apart points are, like on the coordinate plane. Now the next formula we have is the midpoint formula. Okay, midpoint is the middle of like a line segment. So if I'm looking at 2 points on the coordinate plane, if I drew a line segment to connect them, and I wanted to know where exactly the middle is, like where's halfway between those points, I would use the midpoint formula for this. So you're still going to have 2 coordinates given to you. I'm still going to label them x1, y1, x2, y2. I'm just going to use this formula instead now. So we're going to add our x's, so add your x coordinates and add your y coordinates, and you're going to divide them by 2 because you're cutting them in half. You're figuring out the x's are here and here, and I'm going to add them and divide by 2. It's like finding the average of something. So for this first one, 2, 4, and then negative 115, again, you can start by labeling it x1, y1. If this helps you, so that you kind of know where the pieces then need to go in your formula, I would label all of these this way. So we're going to do x1 plus x2, so that's going to be 2 plus negative 1, and we're going to divide that by 2. And then for the y's, it's going to be 4 plus 15, and we're going to divide that by 2. Now when I write it, I'm putting it in parentheses and I'm putting a comma in the middle because I'm finding a new coordinate. Because again, if I graph this, the midpoint would be somewhere in the middle and it would be representing another point on the coordinate plane. So 2 plus -1 is going to be 1 over 2, so that's a half. And I'm going to go ahead and just leave it as the fraction. And then 4 plus 15 would be 19, and that one's also over 2. So again, I'm just going to leave it as the fraction like that. I don't need the decimal. So that would be the midpoint of those two coordinates at 1/2 and then 19 over 2. You guys try number 2 there on the bottom of that page. All right, so I plugged that one in and I got the answer 2 and then -9 over 2. Let's turn our page over here. We're going to continue to use that midpoint formula, but they're going to change it on us just a little bit. Instead of us finding the midpoint, they're going to give us the midpoint and they're going to give us one of the endpoints and we want to find the other endpoint. So it's kind of like I have where the line segment starts, I have where the middle is, I need to figure out where the end of this line segment would be. So where's another about halfway distance away from that midpoint. To do this, I'm still going to, like I said, use that midpoint formula. So remember, the midpoint was when I added my x coordinates and divided by 2. Now in this case, I only have one of the x, y values. So what I do is I start by taking the midpoint points, so like the 7 and the 5. And I'm going to set something up that equals those two numbers. So I'm taking, to find the 7, I took my two x's and I added them together and divided by 2. I only know one of the x's from the endpoint, and that's the 4. So we write 4 plus x, because x represents the other missing endpoint coordinate, and we're going to divide that by 2. Now we're going to do the same thing over for the y endpoint. So 0 is given to me, so I'm going to do 0 plus y and divide that by 2. So like I said, the x and the y represent the missing endpoint. So the other x1 or the other like x and y that I was missing to get to that midpoint. So the first step on both of these is I would get rid of that fraction. So get rid of that 2 out of the denominator by multiplying both sides by 2. So over here on the left side now, it says 4 plus x equals 14. So then I'm going to subtract 4, and so x equals 10. Okay, and then I'm going to do the same kind of math over here on the right side. I multiply by that 2 first, so that's gone. 0 plus y is just going to be y. And then 5 times 2 is going to be 10. So there's the y. So if I wanted to write it as a coordinate, the other endpoint would be 10, 10. So you guys try to do number 2. Okay, so how I set it up, I did -2 plus x over 2 equaled -5, and then -6 plus y over 2 equaled -9. I solved it the same way I did that last one. I multiplied by 2 first to get that fraction to go away. And then for my x, I got -8, and for my y, I got -12.